Okay, good morning, good afternoon. Hello, everybody. Today is July 14, 2021. This is the bi-weekly SIG API Machinery from Kubernetes meeting. We are meeting today. We have one topic in the agenda from Mike Spreitzer. We are going to try to time box it in 30 minutes. So why don't we start? Mike, are you there?
Yes, I am. Thank you.
Okay.
All right. So I'm getting in interested in Edge and IoT topics, and looking around at problems and existing work. A couple of the driving problems seem to be nodes that have small resources in terms of, say, compute and memory power, and the need for operating in extended periods of disconnection. And it seems to me that we could cope with this by basically extending the functionality of the API server onto the individual node in some way with some sort of caching, proxying type functionality. And I have discovered, in fact, other people have figured this out too. There are a couple of existing projects, actually 3 existing projects I looked at that all more or less take this approach. And the thing I wanted to talk with you people about is, maybe we should be doing something coherent upstream rather than having a much different independent downstream projects doing this. So I'm specifically thinking of Kube Edge and OpenYurt and Super Edge. They all take the approach of having a bit of API server cache on the edge node, all somewhat different in their technologies. So again, my point is, maybe we should be doing something upstream. And 2 approaches have occurred to me. The simplest, and at first I rejected it because it doesn't really support integration between processes, but there are some very resource constrained use cases for which that may be an acceptable restriction. And in this case, the simplest approach would be to develop a caching layer for the client set. And then if you do want integration across things on the node, the next step would be a caching API server proxy. So those are the things I put on the agenda. And maybe I should stop here and take brickbats.
In a caching approach, how are writes handled?
Well, as I said, there are 2 varieties of this. So let's start with the simpler one. In the caching client set, that's simpler because it doesn't need to impersonate or anything like that. It can just use its regular identity. So the client set, of course, has an API that the higher levels of software use. So the trick there would be to simply, there's 2 sides of it, of course. I think your question is about, obviously the writes have to be buffered up in an appropriate way and then delivered when possible. So the trick there would be, for example, if there are successive patches, figuring out what patches can be merged. Again, for extended disconnection, it's likely that there are patches that overwrite each other, and we would want that savings.
Sorry for interrupting. Let me suggest an even simpler one, which is don't cache the things at all. You cannot write if you have lost your connection.
Yeah, I don't think that's very viable. For example, we want to survive reboot and process restart. The kubelet does some writes, so we need to allow that to happen.
If you're having a client set maintenance for you, if you restart, it would seem that you would lose that client set state. It seems also that a client set would not allow anything other than a Golang process realistically doing this. And that seems very restricted.
So I didn't say that the cache is kept only in memory. In fact, I was specifically thinking that the cache would be kept on disk so that indeed it would survive a process restart. You're right, obviously, a client set is language specific. So this solution would have to be developed for each of the languages that you want to use it in. So the other, let me finish answering the question on the other side then. For the caching API server proxy, again, the writes would need to be cached on disk or whatever the local storage is. That adds several bits of complexity. I think once you get to the point of wanting to support multiple processes, you need to support some independence in their evolution of the versions they deal with. So you need the version conversion machinery from the regular API server. You need to deal with impersonation, because this thing, when it reconnects, it's not going to run as every one of the local clients. Presumably, it would need to run as something that's authorized to impersonate them. I'm thinking probably the best way to do it would be basically to take the existing API server process and is looking at where to shim it in. Basically somewhere between the REST handlers and the etcd storage would probably be the right place to shim in this caching layer.
I would agree that you could put a caching layer in there, but I don't see a viable way to do writes other than the one I described. Because
Right.
it's a multi-actor system, right? Like
It is.
So, and people other than the local system could be modifying the objects cached on the local system. So even if you can successfully combine and apply all the caches all the changes locally, it's not clear how to then guarantee that that stuff will get incorporated into the upstream or the like source API server.
So let me be clear. I'm sort of working on expanding what's possible. I'm not necessarily claiming I know how to, or we will be able to, do a fully general job. I want to look at, how good a job we can do. That said, can you elaborate on the difficulties you're thinking about?
I mean, it only requires a change from an actor on the cache system and a change from an actor on the like main connected to the main API server that conflict in some way.
Okay. Yes. So the basic inspiration here is kind of the use case or usage pattern that I think this works for, is where every bit of state, and maybe I'll even say bit, every bit of state has one author. And since we have these managed fields metadata, we can tell who's writing which parts of the object. So as long as each bit has only one author, it should be possible to combine writes from different authors because they're going to different parts of the object.
I mean, I see a problem though, even with something like a list watch, right? If the resource versions don't match, and you have created synthetic resource versions to reflect your own rights, then you will have an alternate history when you reconnect to a real Kube API server, resulting in two parallel conflicting histories. I don't see how clients handle this.
Yeah, actually, that's an important question, even for the caching client set. Yeah, I'll have to think about that. I'll just say, the out that I will say is that we have a discipline that we've been trying to promote, right? That says that the resource version is not necessarily just a number; it's an arbitrary string. So if we had some kind of a version vector sort of string, we might be able to get that way. Now, of course, the first thing you ask yourself is, oh, well, I was assuming these things are all comparable to each other, and vectors are not all comparable to each other. But that may not be what's important. The important thing is, when you need to do a relist or a watch, you need to, pick up from the point where things last were. And that's a little bit more doable with, you can combine version vectors. So you can say, okay, here's the combined vector point I need to resume from. But I'm going to have to admit, I haven't worked all that out.
Going back to the other point, maybe we could lock down and require on such objects that nobody is allowed to force conflicts, and then the system would work. But I'd have to think about that a lot. Sorry,
Well, that's where I was going.
Yeah, there's a hand up. We should.
Oh,
Gary, am I pronouncing that right?
Oh yeah, Gary. Misspelled, but Gary. Yeah, I guess it's an interesting topic because you know, I had thought of similar ideas, but I guess maybe a couple questions to Mike and then maybe to the group here. I guess Mike, like, what's the there's other efforts around trying to make smaller singular standalone clusters, right? Microkube and K3s, right? Which I know K3s kind of basically they're just single node clusters, right? That have pretty small footprint. I guess you're looking to kind of do the notion of remote nodes, or you think that we still should have a master and going out there? And then, are there a lot of updates in here? I mean, maybe this is a terrible answer, but why would, if you still wanted some level of communication in the control plane, don't like static pods work to a degree here for you? If you're concerned about just the workloads being able to restart and the kubelet restarting, as opposed to the caching layer. I guess maybe for everybody, if those make sense. I guess that's kind of because I had these similar thoughts, but I was just wondering about those areas as well.
Sure. So I'm looking at a variety of scenarios in really, I think, I work for IBM. We're a vendor, and I'm talking to this general group about the project in general. So I'm seeing a desire to really support a spectrum of use cases. And when people talk about edge and IoT, they talk about a variety of capabilities of nodes. Some of them are very resource constrained. So that's why I am interested in thinking about how low can we go, right? Walter has a question also. Did I talk to Steve Wong in the Edge IoT group? I did actually go to their last meeting and raise the topic there. In fact, they're the ones that pointed me to OpenYurt and SuperEdge. And so to your question, right, a few things. So just the kubelet, it already is doing some writes. And as I've been discovering, we don't document it clearly at all, but static pods are very restricted. The spec of a static pod cannot refer to any other API objects, not even a service account. Not a config map, not a secret, not a volume, nothing. And maybe that's okay for these use cases. I guess my primary answer is I want to look at the spectrum. I mean, certainly I believe there are edge cases where you can afford to run a full regular cluster. I do also want to have a little bit of a question of, do we really want to make it do we want to make it look like a cluster? I mean, in some cases, it is just a node. Do we want to introduce a multi-cluster problem when we don't need a multi-cluster problem? Again, the kind of the top level point I got from the Edge IoT group, their charter says they're going to come up with a reference architecture. And I asked, how's that going? They said, oh, well, we realized there's never going to be one reference architecture. The use cases are so different. There's just a collection of architectures that get developed. And that makes sense to me. For my own looking at this problem space, indeed, the use cases are different. And the architectures are actually evolving, frankly, like in the automotive world, right? Today, you've got this collection of very special purpose controllers that communicate in very fixed hardwired ways. And there's a lot of architectural evolution to come in your car. And it's by no means settled down what the future architecture is going to be, nor even what market segment, what kind of players are going to be defining it. Is it going to be Google, or is it going to be Toyota, or is it going to be the parts suppliers? I mean, there's all sorts of unknowns, as well as variety. So I really believe it's appropriate to have an emphasis on at this level, from this group, right? We want to look at providing technology options and seeing what leaving it up to users to figure out what works for them. All right, and K3s, right? That's one company's distribution. You know, that doesn't work for everybody, right? We have a lot of other distributions that say we're not going to distribute, you know, Rancher. That's just not working for us.
Yeah, it's actually been donated to the CNCF now, which is interesting. Let's take Jack has had a hand up for a while, so let's get that question out, and then we can circle back to some of these topics because I don't think we're done discussing.
Hey there. This is my first time joining API intrusion. I filed a bug a few years back, and I'm testing to see if it's still a live issue or not. I've just pasted it in chat here. That actually does block even normal kubelet operations when the API server goes away. It's sort of independent of anything that we're trying to do asynchronously. This is, you know, purely about running workloads when they can't talk to when the kubelet can't talk to the API server. I don't know if there are other issues out there like this, but the fact that this one existed made me wonder if this is even a test that we exercise very much. You know, just in terms of what happens to pods that are running and aren't expecting to hit the API server when the API server goes away.
Yeah, and actually, you know, thinking about implementation, this raises another, you know, long-standing issue I have come up against for other reasons, right? Which is, how is the kubelet going to keep itself appraised of the contents of the relevant config maps, right? You really want some kind of a dynamic informer with a dynamic filter. Yeah, that basically that kind of functionality is what you'd need to fix this problem.
Yeah.
Yeah, that bug looks like it should be fixable if kubelet watched the relevant config maps. I believe it does watch some. It watches config maps that are mounted. I don't know if it watches config maps.
Yeah, that's exactly what we call it in the bug. That config maps that are mounted don't suffer from this problem, but config maps that are consumed through other mechanisms do. Yeah,
I think it's a legit bug, and it probably shouldn't have been closed. But it looks like that's a SIG node bug, and it looks like it's fallen off their radar. If you want that fixed, you'll probably have to do some championing of that issue.
Yeah, understood. I let it drop because frankly it fell off my radar too.
Yeah.
Right, but I agree. This is relevant, right? Because what I'm trying to say is, I think the right focus here is to look at separable technology issues, and this business about being disconnected is one of them, right? So we'd like to be able to have a node tolerate disconnection, right? And this would be, you know, just one part of that overall campaign.
Is that a test or a case that we exercise in end-to-end testing or anything right now?
No. It's not even a supported case now, right? The way the code works is it's really predicated on the idea that we're running in a high connectivity environment. It's shot throughout the code, the assumption that you should be able to communicate back to the control plane central nodes whenever you want to.
Okay.
I think you may have hinted at it, Mike, but there's another model, which is just you run completely separate API server with maybe a lightweight storage on the node, and when the node has network connectivity, maybe elsewhere in the cluster, there's a syncing routine that just copies changes back and forth. Right? That sidesteps the problem David pointed out, where like you have alternate histories, and potentially also sidesteps the problem of people have conflicting writes, because the syncing routine can decide which things to keep and which things to change.
Or rather than sidestep, I would say solve it, right? Because that would be an approach, right? If you do have the use case that each bit of state has only one author, then the syncer can do a merge, and there is no issue of multiple sources of resource versions.
So yes. I was wondering how that kind of compares to like the federated approach where like you bring API, you have more API servers, but you bring them really close to the thing that you want, like maybe in this case, the node. And then it could be that like the node can keep writing to that API server, but when it gets partitioned, nothing else can reach it. So you kind of lose the rights on the other side. I was wondering how that kind of compared to what you need.
Well, I think really to complete it, you get to what Daniel was saying. You need, if you have kind of this satellite API server, right, you need something that keeps it in sync with the main API server while they're connected. And yeah, I didn't like that approach at first because it's, it's adding more mechanism. And in fact, the syncer, I think you would want to run, you wouldn't want to run a bunch of syncers in the central place. You'd want to run the syncer, kind of in a pull mode rather than a push mode. So now you've piled on more resource usage. So, for that reason, I'm not enthused, but I'll agree, it's a way to answer the technical problems about the resource versions.
All right, I think this is a really interesting topic, and we've had a good discussion, and I think we've outlined all the solutions that I'm aware of. I think it's difficult to decide what the next step is because it's very abstract, right? As you mentioned, there could be a lot of different use cases, and that makes it pretty hard to decide in the abstract on a model. And maybe the answer is like all of the models are valid and should be done in different contexts, but there's only so many of us, and we only have so much time.
Okay, so I can maybe make this a little bit more concrete. All right, as I mentioned, there are existing projects, OpenYurt and SuperEdge, that kind of broadly follow this, but again, they're downstream, right? So a little bit more concrete version of this is, could we upstream the central ideas from them?
I would want to have, like, are they interested in that? Would that save them effort or add correctness or something like that? And right, it's not just up to us.
Right. Yeah, and I haven't raised it with them.
And
yet.
I wouldn't want to compete with them unless they're right. Like I wouldn't want to introduce a competing effort unless we've got some compelling reason to do it.
Yes, understood. So as I said, maybe when I was mute, I haven't asked those communities yet. I can only ask one at a time. So.
Yeah. No. I'm not saying you should have. I mean, maybe it hasn't even occurred to them that it's even an option to have a discussion. I'm definitely always happy to entertain the idea of incorporating advances made in other open source projects. That sounds great if they're amenable to it, and it is helping all of us.
Right. Thank you. So I'll see about contacting those groups.
Yeah, maybe even just open an issue in one of their repos. If you feel free to tag me. Yeah.
Daniel, do you see it as a foregone conclusion that we should adopt such a project if they are interested, or do you see it as a prerequisite for us to even consider it that they are interested?
I don't think it's a foregone conclusion that we would take something like this. I think it is a foregone conclusion that we wouldn't if we don't have a good reason to do so, and like interest from the owners is potentially a good reason. I wouldn't say it's always going to be a good reason. I think we need more than that, actually. I think we also need some, I think it needs to solve some problem for either the Kubernetes project or for API Machinery.
I think you're agreeing with David's second alternative, right? It's necessary but not sufficient.
Yeah. Does that sound right to you, David?
It does. I just want to make sure that we're on the same page and don't accidentally send Mike out and he goes like, "Hey guys, you want to come over?" They said yes. And then they go, "Yeah, that sounds awesome." And they show up and like, wait, no. So
Yeah.
so I see it as necessary, but not necessarily sufficient. I haven't in my head thought like, I have not yet made a reasoned argument really one way or the other that convinces me.
Yeah. Yeah. I mean, I'm personally slightly interested in like caching, I think, but mostly because it's cool and awesome and it's something we could do. So at this point, it feels like a solution that is looking for a problem for me.
Well, I did come to this from a problem perspective, so I believe it does solve some problems.
I see
Sure.
it as awesome, and I am less sure that we have the solution.
Yeah, that's totally fair. Mike, yeah, I agree. You came from that perspective. I still feel like the problems are abstract.
Fair enough, right? So, and yeah, I'm not quite sure how to sharpen it up, but we're reaching the end of this allocated box. So we'll stop there for now.
Yeah, sounds good. This is if nothing else, this is a good reference conversation. All right. Anything else, Fede, or should we wrap it up?
No, I think we are done for today. Code freeze was a couple of days ago, so I think we are in a good shape there. Either I didn't see it or was not as bad as other, code freezes, because I think our approvers survived. I mean, I didn't see them as crazy as last time, but they were busy. So thank you everybody for the effort. Somebody was asking about the meetings. Just subscribe to the mailing list and you will get the invites automatically. And everybody's welcome to join us in the PR and Back to Ashes twice a week. Thank you for joining today. I hope everybody's staying safe and having a good summer, at least in the Northern Hemisphere. Winter if you are in the south one. We'll see you next time. Okay. Bye-bye.